Okay, guys. So, today, our Do Now has 2 questions. And the first question asks us to write the equation in slope-intercept form, that's y equals mx plus b, of the line that passes through these 2 coordinates. So we're given the coordinate 3, 6 and 6, 15. Now, what do we need to do in order to write an equation? Does anybody have any ideas of a good place to start? Yes, Bree. Yes, I think sometimes if we don't know where to start, just start by labeling everything. So I just picked up blue first, so I'm going to label my y's first. I'll call this y1, and I'll call this y2, so I don't mix them up. Then I have x over here, x1, and x2. Okay, what else should I do? Plug them in. What am I going to plug them into? Ooh, yes. Guys, we're going to use the slope formula. Before we can write any equation, we have to solve for our slope. We need a slope to have an equation. So I'm going to write out that formula as just a little reminder. We're going to be doing y2 minus y1 over x2 minus x1. Okay, so now give me those numbers that we're going to plug in. 15 minus 6 over 6 minus 3. Okay, and what are we going to get on the top number? 9. And what is 6 minus 3? 3. So our slope is 9 over 3. Now we could simplify this, that's right. What would 9 over 3 simplify to?
3 over 3.
Yeah, 9 over 3, you could just put it in your calculator, but we know that this is going to be just a positive 3. That is my slope. So I'm also going to label it, I'm also going to label it with my m, because slope is m. All right, now we have a slope, we have some x's and some y's. What should we do next to get us a step closer to having an equation?
We're going to use our y equals mx plus b.
Yes, we need to use the slope-intercept formula. I'm going to rewrite that down here. Y equals mx plus b. And what'd you say?
I chose to plug in the first set of coordinates, 3 and 6.
Yeah. So we now have our m value, and we have some x's and y's to choose from. I always like to pick ones that are not negative and are not big numbers. So in this case, we'll go with the first coordinate because it looks like it'll be the easiest to work with. So I'm going to plug in 3 for x and 6 for y. So directly to the side here, here's what I'm going to do. I know I'm going to do y equals, so I'm going to write 6 equals, my m was 3, and then I need to plug in my x value. What's that? 3. Good. And then I don't have a b value yet. I don't know my y-intercept. So I've got 6 equals 3 times 3 plus b. All right, what should I do from here?
3 times 3.
Yeah, what's 3 times 3?
9.
9. Bring everything down. I've got 6 equals 9 plus b.
Then we're going to do inverse operation.
Yes, we want to use our inverse operations to solve for b. So what am I going to do to get rid of 9?
Subtract.
Good. We're subtracting 9 from both sides. And that's going to give me what?
-3.
Good. -3 equals b. Okay, so I have my slope, I have my y-intercept. I just need to write an equation. And remember, when we are writing a linear equation, we want to keep y equals, and we want to keep slope x. We don't want to plug anything in for x or y in that final equation. So we are going to put y equals what?
3x.
3 for m. So 3x. And then yes, we got a negative 3, so we're going to just write minus 3. Y equals 3x minus 3. That's our equation, guys. Good job. Did anybody get something different? If anyone in this room did get something different, do you understand or see how we got this now? Okay, good. I see some heads nodding. That's good. Okay, any questions before we move on to number 2? All right, so let's go on to number 2. Now, I did not give myself very much room to do my work, so I am going to just fold this over and attach another paper here. All right, so we found our equation. It was y equals 3x minus 3. I'm going to rewrite that. You can't see what I'm doing yet, but you'll see it here in a second. Y equals 3x minus 3. And then I want to write the equation of the line that is parallel. I'm going to kind of abbreviate it by just drawing these 2 lines. I want to write the equation of the line that is parallel to this equation we just found. And it goes through this coordinate that I gave you. Okay, the coordinate is 10, 20. Okay, so I am given an equation, and I am trying to write a new equation that is parallel to this one, and it's going to be going through this point. First of all, what do we know about parallel lines and their slopes? Does anybody remember?
They never cross.
Yes, parallel lines do not ever cross, so they are going to be going at the same angle. They never intersect. What else do we know about parallel lines?
They can go any direction.
They can go any direction as long as they're going in the same direction. What do we know about their slopes?
They're always straight.
They are always going to be a straight line. If it's got a slope, that part's correct. Let me ask you this. Are parallel lines going to have the same slope or a different slope?
Same slope. Parallel
Same
lines have the same
slope.
and they
Yes.
never touch.
Exactly. So I'm going to show you something real quick, slightly related to this problem we're doing here. For example, if I have 2 lines on my graph, and this you don't necessarily have to write, I'm just showing you visually as a little bit of an example here. This is more of a visual aid. If it does help you, you can write it, but you don't have to. Okay, so
Arrows on
let's say that I have this little graph here. Y'all done? Perfect. Yep, just put it there. And I'm going to label my X and Y axes just so I keep everything straight. And let's say that I have two lines. I'm going to trace them real quick. And I'm going to tell you right now, these are going to be parallel lines. All right. Make that a little more precise for me. Here is my first line. Here is my second line. All right, maybe I'm being too picky. Come on. Okay. So, let's visually see if we can figure out the slope of each line by counting our rise over run. So let's start with this line here, the one on top. How am I going to count my slope here? What would I do?
On both lines, or just one line?
Just on this first line.
Well, count up to. Count up to.
Yeah, so I'm counting my rise and then my run. And what we just found here is that my rise is 2, my run is 2. So my slope would be 2 over 2, which simplifies to 1. So I have a slope of 1 here. Okay, let's try the other line here. We're going to count the same way. We need to find our rise and our run. Yeah, we're going to get the same thing. We've got 2 for our rise, 2 for our run, so 2 over 2 is going to simplify also to 1. So anytime two lines are parallel, they will always have the same slope. They will never, ever, ever have a different slope. If these lines didn't have the same slope, then they would not be parallel. That is a rule that will never change. It's like a law. To be parallel, they must have the same slope. Okay,
So what if the tops are in a different place on the bottom?
like if I had one here and here. Okay, well we do the same thing. Rise would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And then my run is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 over 11 simplifies to 1. You're always going to get the same slope. Even if your numbers are different, they're going to simplify to the same thing. Because our slope is just the angle that our line goes at. So these have the exact same angle here. They're going at the same steepness. That makes sense? Okay. Let's look at this problem now. So, if we are trying to find the equation of a line that is parallel to this line, what is something that we already know about the new equation? We know the slope. What's our slope going to be? It's going to be 3. If it is parallel, it has the same slope. So we already have a value for m. Yes?
So do we plug in with the y equals to it's supposed to be?
Mm-hmm. You're just writing another equation? That's it. That's it. That's totally it. So now we have our slope, and then remember the steps that we were learning about the other day was step 1, find m, which we just did. Step 2, solve for b.
So we're just going to solve for b again.
That's it. Yeah.
And then that will make it parallel. So,
Yeah.
So it's just more intimidating than
Yes.
been when I, because I haven't looked at it all yet.
Yep, it's just a different way of doing it. It just sounds a little bit scarier, but it's really not that bad.
Yeah.
It's not that bad.
Okay.
So we have our m is 3. So let's go ahead and write y equals m. So I'm going to put my 3 in there. X plus b. Okay. So step 1 is done. We found our slope and we put it in the equation. Now I'm going to go ahead and label my coordinate. And the only difference here with my old equation and my new equation is that I'm going to be plugging in different values for x and y. So I'm going to come up with a different value for b. So let's go ahead and do that. How am I going to rewrite this once I plug in my x and my y?
It's going to be 20
Mm-hmm.
equals 3. And
Yeah.
it's going to be 10.
Perfect. 20 for y equals 3 times x, which is 10, plus b. Good. It's not so bad, guys. Once we break it down into steps, it's not so bad. Okay, how do we solve this?
3 times 10.
3 times 10 is
30.
30. We bring everything down. Now what?
Subtract 30.
Good, subtract 30. And my 30's cancel. 20 minus 30 is
Negative 10.
negative 10 equals b. So step 1, we found m. Step 2, solve for b. We just did it, guys. We know that b is negative 10. So now that we have our m value and our b value, all that's left to do is to write that equation. So what is my final equation going to be?
Y equals 3x
Minus
10.
Yes, y equals 3x minus 10. The only thing that will ever be different in an equation about parallel lines is the b. The y-intercept is the only thing that will change. So as long as you can remember the rule that parallel lines have the same slope, you all can do it. It's not so bad. It's not so bad. Okay, let's talk about what we're going to do today. I'm going to give you the lesson plan. Does anybody else still need to write any of this down, or can I move it? Okay. All right. Here is what we are doing today. You don't have to write this. I'm just showing it to you so you know what to expect from me. We are going to go back to the basics. Make sure everybody feels great about writing an equation in general. We're just going to practice that for a minute. Then we're going to review parallel lines. Make sure everybody feels good about that. And we are going to learn a new thing today. We're going to talk about perpendicular lines. And we're going to learn a fancy word. We're going to find out what negative reciprocal means. So, this is our plan today.
So the first two is just review of what we've already done?
Yes. First 2 is just review of what we've already done. I try not to introduce too many new things each day, so I like to kind of recap what we did before just to make sure everybody's on the same page. So, let's just quickly review how to write an equation. So, whenever we are writing an equation, for right now, we are only learning how to solve, or not how to solve, how to write an equation in slope-intercept form. Y equals mx plus b. And remember, our goal in writing the final equation is to have it look like this. We're going to have y equals, then we'll have a number for m, with an x, plus a number for b. So we don't ever want to have something for y or something for x in our final answer.
It's always just M and B. Slope,
Just
and
M and
solve.
B. Yep, because this is called slope-intercept form. And all that means is that our equation tells us the slope and the y-intercept. Slope-intercept form. So let's label this too. Our M is our slope. And our B is our y-intercept. So the B is going to always tell us where the line is touching the y-axis. All right, guys. So, let's review those steps. Whenever we are trying to write an equation, step 1 is always to find your slope, to find M. Now, in some problems, you will be given slope. You might say, here's the slope of the line and a point it goes through. Solve for finding the equation, or not solve, write the equation. I keep saying solve, guys. So, sometimes you're given slope. If you're not given slope, let's say you're given 2 coordinates, that's when we would use our slope formula that's up here on the board. That M equals the y2 minus y1 over x2 minus x1.
And that, I think I remember you always do like the second one first, the second coordinate.
Yeah, and you know, whenever you have 2 coordinates, it doesn't actually matter which one you put first and second. It just matters that you're consistent with it. So if I want to do second coordinate minus the first on top, yes, I got to do it on the bottom. If I want to do first minus second on top, then I got to do first minus second on the bottom too. It doesn't matter the order as long as you're consistent with it. Okay. So once we find slope, whether it's given to us or whether we have to solve for it, step 2 is to solve for B, or our y-intercept. Oh, that is not orange. Looks like it to you guys though. So we're going to solve for B next. And we do that by plugging a coordinate into the equation. Okay. So that's how we would solve for B here. By plugging it into y equals mx plus b. And we're trying to find out what our B is. Once we've done that, step 3 is just writing the equation. So I'm going to say write the equation. And your final answer is going to be y equals a number for M, X plus a number for B. All right. So those are your steps. There's a review of how to write an equation, guys. I'll give everybody a minute to write. If they need to, I'll pause this recording real quick. So we just reviewed those steps for how to write an equation. So we're going to go on to the next thing, which is reviewing parallel lines. So what I'm going to do here is I'm going to have you guys kind of create a guide along with me that's going to help us to remember the difference between parallel and perpendicular lines. So we're going to make 2 columns. In the first one, I'm going to put parallel lines. And in the second, I'm going to put perpendicular lines. Okay.
Odd word to define right angles.
I know, perpendicular. I wonder who came up with that. Who knows? So, what I'm going to do is I'm going to create 2 columns, like I said, just so we can kind of tell the difference between the two. So for now, I'm just going to do about like that. I don't know how far down I'm going to go on the page, so I'm just going to about there. Okay. First thing I want us to do is we're going to draw a little picture for each of them. So to make my lines look really nice and parallel, I'm just going to use my blue lines on my paper, and I'm going to draw 2 lines that are parallel to each other. These are parallel lines. And the way that we indicate that lines are parallel is we just put a little extra arrowhead in the middle of our line on both of them. So these little symbols tell us that these lines are parallel. Now, once you've done that, we're going to draw perpendicular lines. I'm going to start with one line going as close to straight up and down as I can. And then I'm going to draw another one on one of these straight lines like this. And the way that we indicate that lines are perpendicular is we put a little box in one of the corners, which means that we have a right angle. Lines are only considered perpendicular if we have a perfect right angle at the intersection. And a right angle is an angle that's exactly 90 degrees. Exactly 90 degrees. So an example of a right angle, in case any of us are a little dusty on the subject, it's any like corner of a page or edge of a square, you know, those things that are going to give you that perfect 90-degree angle is a right angle. So if you're ever questioning it,
So perpendicular line, this is a 90-degree.
yes, yes, perpendicular lines always intersect at 90 degrees. So if I wanted to, we're not measuring angles yet, but if I wanted to measure these angles, this would be a 90-degree angle, and this would be a 90-degree angle, and this would be a 90-degree angle, and so would this. If any of those angles aren't 90 degrees, they're not perpendicular. But I'm not going to have any questions where I have you tell me by looking at it, is this perpendicular? Just know that if it has a little box in there, it is perpendicular. Okay, so now let's talk about the slope of both of these types of lines. So I am Gonna start by just writing slope. So I have a little section for slope on both of them. And what do we know about the slope of parallel lines?
The same.
Yeah, so I'm gonna write here under slope, I'm gonna do these two lines for parallel, so I don't have to write the word out every time. Parallel lines have the same slope. And I left a space because I'm gonna write it in green. Now, let's talk about perpendicular lines. So I'm going to draw a little mini perpendicular line here. Perpendicular lines have, what'd you say, Star?
Aren't they gonna be intersect and touch?
They do intersect and touch, absolutely. But their slopes, we're going to learn a new word here, guys.
Oh, that's that in blue you just.
Uh-huh. So perpendicular lines have what we call negative reciprocal. Slope. Negative reciprocal. So today we are going to learn what that means. And I'm going to have you in this chart. Underneath that, we're going to write some examples for each type of line so that when we are taking a quiz later on, you can go back to your notes and find this chart we made, and you can always see what you need to do when we're finding a parallel line or perpendicular line. This is going to be your cheat sheet, guys. So, for example, let's look at parallel lines. We'll go right back to perpendicular in a second here. If I had a slope of 2, what is the slope of my new line? 2. So I'm going to write, guys, original line and new parallel line. What if I had a slope of negative 2/3? What would my new slope be? It would stay the same. It would be negative 2/3. Okay, and one more just for good measure. What if my slope was 1,000? It would stay the same. It would be 1,000. Good. So parallel lines, when we're trying to write the equation of a line that is parallel, that slope will never change. Now, for negative reciprocal, we're going to do something different. I'm going to write original line and then our perpendicular line. So I'm going to give you some examples here. If my original slope was 2, for example, the first thing that we would do is we want to put it in rise over run form. So what would 2, just the whole number 2, be in rise over run? How do I make that a fraction? 2 over 1. Perfect. 2 over 1. Now to find the negative reciprocal for the perpendicular slope, here's what we do. We make it negative and we flip our fraction upside down. So our new slope is negative 1/2. What if I had a slope of -5? What's the rise over run form of that?
Over 1.
Yeah, just put it over 1. -5 over 1. So the same thing as before, we're going to change the sign. So since it started as negative,
Goes to positive.
it goes to positive. Exactly. This time it's not negative, it goes to positive. And then we flip our fraction upside down. So our new slope would be positive 1/5. And it sounds scary, but it's really not so bad, guys. It's just 2 little baby steps we got to do. Let's do a couple more examples, and then I'm going to have you guys practice doing this process for a minute. What if I had a slope of 2/3, 2 over 3. It's already in rise over run form.
We're just gonna flip it and make it negative.
Yeah, you're just going to flip it and make it negative. So your new
Negative 3
slope,
over 2.
yep, -3 over 2. That's it. It's not too bad, guys, is it? That's not too bad. So negative reciprocal just means that we make it the opposite sign. So if it's negative, we make it positive. If it's positive, we make it negative. And then we just flip the fraction upside down. So let's do a little bit of practice. I'm going to write down here six different slopes. And I want you to find the negative reciprocal of all of them. And I'll give you a couple minutes. So we'll start with
Do we have to draw that line?
nope. I just want you to find the negative reciprocal for now. Okay. Just find the negative reciprocal of all of these slopes. And I'll pause this real quick. All right, so I'm going to label this. Find the negative reciprocal, and I'm going to abbreviate here, of each slope. Okay. So, what would be the negative reciprocal of 4/5?
-5 over 4.
Absolutely. -5 over 4. What's the reciprocal of -3?
Positive 3.
+3 over 1, and then what?
Flip it.
Then we got to flip it. So what is it?
1/3.
It's going to be +1/3. Good. What's the negative reciprocal of 7 over 2?
-2 over 7.
Yes, -2 over 7. Very good. How about this one? -4 over 3.
3 positive 3 over 4.
+3/4. How about 17?
-1 over 17.
Yes, -1 over 17. And how about -40?
1 over 40.
1 over 40. Awesome. Did we get those? Good. Okay, guys, I think we're ready for the next step. Does anyone need to copy any more of this down, or are we ready to move on? Okay. I'm going to rip this out, and we are going to start page 4 of our notes.
I think a couple of people needed this.
Oh, you still need it? I'm sorry. Speak up, guys. If you need it, I'm so more than happy to leave it up. Here, I'm going to move that. Okay, shout at me when you're done. Here, I'll pause this real quick. Okay, now we are starting our 4th page of notes for day 18. Okay, so we are going to do some practice writing the equation of a perpendicular line. So that's what I'm going to title this page. Writing the equation of a perpendicular line. And I'm going to draw a little picture up here so I can remember what I'm doing. Okay. So, when you are asked to do this, when you're asked to write the equation of a perpendicular line, you will be given an original equation such as y equals 2x plus 3. And I'm going to say, write the equation of the line perpendicular to y equals 2x plus 3 and goes through the point, let's say 4, 5. Okay. So, remember, whenever we are trying to write an equation of a line, our steps never change. Step 1 is always find M. Step 2 is solve for B. And step 3 is writing the equation. So, for step 1, we need to find out what our slope is going to be for our new line. So how are we going to do that? Yeah, we need to find our M. So what is the slope of the original line? 2. So negative reciprocal is what we're going to be doing to find the new slope. So what is the negative reciprocal of positive 2? Negative, ooh, yes, yes. So if we need to write out this process, that's okay. We're going to have 2 over 1 to start, and it's going to change to a negative, and then we flip it. Negative 1/2 is our new slope. So we have a slope. We're done with step 1. That wasn't so bad. Now we need to do step 2, which is to solve for B, or to find that y-intercept. So what I like to do is to keep track of what we're doing at each step. and plug it in to a new equation. So first we started with y equals mx plus b. We found m, so now I'm going to write y equals, and you don't have to write it all out like this. I like to keep things very simple and organized. Now I have y equals 1/2 or negative 1/2 x plus b. And now what do I need to do to solve for b?
You have to plug in the X and the Y.
Yeah, we need to plug in a value for x and a value for y. Do we have an x value and a y value that we can use?
Yes.
Yeah, what is it?
5 or 4.
Yes, so we know that this new line is going through this coordinate. So I'm going to be using 4 for my x and 5 for my y. So we're going to rewrite it again, but instead of writing y, I'll write 5 equals, and I'm going to put my slope in parentheses so I don't accidentally lose my sign, negative 1/2 times x. What's my x value? 4 plus b. All right. We have everything plugged in except for b. So now we just need to solve for b. How are we going to do that?
Subtract, add 2.
So what we have here, guys, yeah, we have a multiplication problem here. Remember, when we have a number outside of parentheses, we have multiplication. If it helps us feel better, maybe just put them both in parentheses. We're multiplying here because we have m times x, negative 1/2 times 4. So let's see what that's going to be. Negative 1 divided by 2 times 4. This is how I would type that in. Negative 1 divided by 2 times 4 equals. And I get negative 2. Okay.
So you do the whole, you just don't do the top number, you do the bottom too.
Yes, you've got to do both. So what I have here is in parentheses, negative 1 divided by 2
Yeah.
times 4. So that's what I typed in.
So let's do that again.
Mm-hmm. Would it help if I wrote out underneath
Yeah.
the process? Yeah. So what I'm really going to do is negative 1 divided by, sorry guys, divided by 2 times 4 plus b. That's really what I'm doing here. Negative 1 divided by 2 times 4.
I just did it in reverse.
Yeah, and it won't matter what order you do it in because it's all division and multiplication. So we got negative 2. Is everybody okay with that process, or should we explain it a little more? Is anyone confused?
So,
I'm happy to answer questions. Ask them if you need.
equals B.
Not yet,
Oh.
because we still have, look up here at my paper, I still have 5 equals negative 2 plus b. All we did there was the slope times the x. Now we've got to solve. So now I have 5 equals negative 2 plus b. And what do I need to do to solve for b?
Add 2.
Add 2 to both sides. All right, my 2's are going to cancel out. 5 plus 2 is 7 equals b. Good. So guys, we're done with step 2. Solve for b. So I'm going to write over here that 7 is my B. And what's step 3? Write the equation. So what am I writing for my new equation?
So, y equals.
Uh-huh.
Negative 1/2 plus 7.
Not negative 1/2 plus 7. What am I missing?
X.
X.
I remember this.
Good. So we're going to write y equals negative 1/2 x plus 7. You got it. All right. And that's my final equation. So I circle it. Always circle your answers. We want to stay in that habit, guys. That is our new equation. So to answer this question, the line y equals 2x plus 3, it is perpendicular to y equals negative 1/2 x plus 7. Y'all just did it. Good job. Okay, let's do another one.
Perpendicular line, though, when you're solving for it, you always use the reverse. new
Yes,
slope.
always, always, always. Your first step is find your new slope, and you're going to use the negative reciprocal to find it. So let's do another one together. I'm going to flip my page. Does anyone still need this? Going once, going twice. Okay, we have time for one more before lunch. Yes. Go ahead. Oh. I thought you were about to ask a question. I gotcha.
Not this time,
All right.
but stay close.
Okay, so my original line is going to be y equals negative 3/4 x plus 2. And I want to find the equation of the line that is perpendicular to this. And it goes through this point. It's going to go through negative 2, negative 1. Is everybody okay with the way I'm writing this? I'm saving a little bit of time so we don't have to write out all the directions, but here's our original equation. Find the perpendicular line. I'll label that if it helps. Okay. So, our new line. What are our steps for writing the equation of a line, just in general? What's the first step always? Find m. Find our slope. What's our original slope?
Minus 3/4.
Yeah, it's negative 3/4. That's our original slope. That's okay. So, to find our new slope, we're going to use what?
4/3.
Yes, positive 4/3. We're just getting the negative reciprocal. That is our new slope. Okay, step 1 is done. And out to the side, I'm going to write out those steps that we did. This is our slope-intercept form. Now we can plug in our slope. We found m. Okay, what's step 2? Yeah, solve for B. We're plugging our coordinates in and solving for B. So, let's label our x value and our y value. Which one is my x in this coordinate?
-2.
Negative 2. And what's my y?
-1.
Negative 1. So, we are going to plug in y, negative 1, equals 4 over 3 times negative 2 for x plus b. And again, if parentheses help you remember what you're doing, then do it, absolutely. And again, I'll write out what we're typing in our calculator. To find out what my slope times my x is, all I'm doing is typing in 4 divided by 3 times negative 2. Okay, tell me what you guys get for that. 4 divided by 3. I also got 2.6 repeating. What'd you say you got?
2.7.
Okay, 2.7.
Yeah,
Yep.
just rounded it up.
Perfect. So we just rounded. I would take either one. So we know that this is negative, I'm going to say 2.7. Then we need to bring everything down. That's not our b value. We still need to solve for b. So I now have negative 1 equals negative 2.7 plus b. What do I need to do now?
Add 2.7.
Add 2.7 to both sides.
Yeah.
Or 2.6, whichever one you ended up going up with. My 2.7s will cancel. And then what is negative 1 plus 2.7? 1.7. All right, we found our b. We found our b. All we need to do now is step 3, which is write the equation. What's our equation?
Y equals 4 over 3x plus 1.7.
Good. Y equals 4 over 3x plus 1.7. Awesome job, guys. Okay.
So, y equals 4 over 3 times plus.
Yep. Y equals 4 over 3x plus 1.6, if that's what you put instead of 7.
So the last thing on what is gonna do today was the new stuff. None of this is the new stuff, is it?
The new stuff was this. What we just did is new.
So how long is the second part of class gonna be? The whole hour?
Let's see. I mean, honestly, guys, we're just gonna call it today. Here's your exit ticket for day 18. If you want to come back after lunch and get more practice, you're welcome to, but you don't have to. Also, this exit ticket might take a little longer because it's 2 things where you're finding 2 different equations. Just remember, we have a whole week to turn in exit tickets, so if you can't finish today, that is fine. It is also lunchtime. Yes.
I was going to say I have to do that with today.
Say it again.
So I'll probably put the exit ticket and turn it back. Will this be posted on YouTube by tonight?
Yes, it will. It'll be posted in like 5 minutes. All right, I'm gonna go ahead and end the video there and post it on YouTube.